our first example, very simple, show that n plus 2 belongs to big theta of n. So simple. How do you show it? Yeah. If you go back to the two different ways we use to describe big theta notation, you have two different ways, right? One limit way, another inequality way. Yeah. Here the limit way is very simple. Yeah. If you use limit way, you can get the answer immediately. Okay? Yeah. For example, the limit way, you take limit n goes to infinity, n plus 2 over n, when n goes to infinity equals 1. You calculate the limit. 1 is a non-zero constant. Then you can say n plus 2 belongs to big theta of n. That's the limit way. Yeah. Straightforward, very simple. Yeah. Then for the inequality way, yeah. Here, I just want to show you the inequality way. Upper bound, lower bound. You need to find C1, C2, upper bound, lower bound. Okay? Yeah. So let's start. We want to estimate n plus 2 function. Yeah. We want to find appropriate lower bound function and upper bound function in the form of positive constant multiple of n. Yeah. So what is the simplest positive multiple of n as the lower bound? Just n, right? You drop 2. That's simple. Lower bound, just n. 1 times n. That constancy is 1. 1 times n. Drop 2. Yeah. So you get lower bound easily. How about upper bound? Constant multiple of n greater or equal to n plus 2. And there is a n0. There is a hidden n0 parameter you need to fix. Okay? Yeah. All right. Yeah. So for the lower bound, it is true, yeah, because we consider n greater or equal to 0. Yeah. Everywhere, n greater or equal to 0. All right. Yeah. Yeah. So here it tells us C2 constant is 1. Yeah. Then we work on the C1 constant. Yeah. Let us change this expression to n plus n. How about that? Replace 2. 2 is a fixed constant. Replace 2 by n. Do we make this expression larger? When we do the replacement, replace 2 by n, do we make the expression larger? Yeah, under this condition. When n greater or equal to 2, it is larger, right? Yeah, when n greater or equal to 2, we replace 2 by n, it becomes larger. Becomes larger, we use this function as the upper bound function. 2 constant multiple of n. Upper bound function. Okay? So lower bound function, upper bound function. C1 equals 2. C1 equals 2. And n0 for C1, for C2, lower bound side, we only need n greater or equal to 0. For upper bound, C1, we need n greater or equal to 2. But we need both, right? We need both, so we select this one. N should be greater or equal to 2. Then both conditions true. Yeah, yeah. All right. So at the end, we set our n0 equal to 2. Yeah. So you can see our method number 2. You need to do a little more math work here. When you do the math work in your mind, you need to find 3 constants. 3 constants. C1, C2, and n0. Lower bound, upper bound, the condition line. n0, that condition line. All right? Yeah. Sufficiency line. We can also call sufficiency line, right? Passing this line, it is sufficiently large. Before this line, not sufficiently large. Okay? Yeah, we can simply call it sufficiency line. All right? Yeah. Yeah. So for the second method, you need to find 3 constants. Yeah. C1, C2, and 0. Then, why I emphasize this a lot, because this kind of questions I will give in your homework and the tests as a full solution type problem. Full solution, you need to write a full solution. Yeah, in this way, all right? In this way, okay? Yeah.